according to the graph, which range value corresponds to a domain of 2? Anybody know the answer? 4 is correct. Let's talk about why. Which range, which would be a y value, corresponds to a domain, which would be an x value. So they're asking which y value corresponds to an x value of 2. Well, when the x value is 2, that would be over 2 on the x-axis. To get to the point, it's way up here at 4, 2 comma 4. So the answer, though, is 4, because they're asking which range value. All right, now I want you to turn to page 33 in the packet. Okay, turn to page 33. Well, the reason we didn't do 31 and 32 is because I ended up using those problems for the game. Pretty much. I mean, we did 6 rounds and there were 4 on each, so 24 problems. Okay, here we go. Okay, here we go. A function f had the following input and output values. Write an equation to define the function f and use the equation to find the output when the input is -9. Okay, we have an input-output table. What do you know about input values? What else could you call them? X values. And then what do you know about output values? They are your y values. So when you're asked to write an equation, you'll start it with y equals what's going on each time to get from x to y. Like, how are they getting this when the input is 5? Right, dividing by 3. 5 divided by 3 is 5/3. 4 divided by 3 is 4/3. 3 divided by 3 is 1. So aren't they just taking the x value and dividing it by 3? Okay, the second part of this question says, use our equation that we created to find the output when the input is -9. So they've given us another input of -9. What would the output be? -3. Okay, because -9 would go in the x place. If it's an input, you would divide it by +3, which gives you a -3. Any questions so far? All right, number 2. John was given the following input-output table by a friend. Write a function for the pattern in the table. Okay, so this time y equals, right, so you could write 0 times the x value, because every time, if you just multiply the x value by 0, you get 0. But you could also just write it as y equals 0, because it's a constant function. Every single output is 0. Every single y value is 0, so that means it would just be a horizontal line. It's a constant function. To find a function rule for a linear pattern, you would find the slope along with one of the input-output pairs in the pattern to determine the y-intercept. Then write the rule in slope-intercept form. Well, fortunately for y'all, you're not going to have to do that. I have changed up these problems. And so you're not going to be writing the rule in slope-intercept form. I've already given you slope-intercept form, and you have to use it to complete the table. Okay, so for this first one, I would rather you just watch what I do, and then after I've done it, I'll give you time to copy. Okay, so just watch so that you don't miss anything, and then I'll give you time to copy it. Given the function y equals -1x plus 3, complete the table. Okay, well, we already talked about the fact that the input values, like 2 and 6, are also known as our x values. And output values, like -1 and -5, are the y values. So, if 2 and 6 are x values, I can rewrite this equation, but instead of writing the x, I'm going to replace it with the x values, 2 and 6. Now I just solve that, or not even solve it, you just type it in. What is -1 times 2 and then plus 3? 1. So when your input is 2, the output is 1. Because don't you end up with y equals 1? So that's why we put a 1 in the y column. Okay, what about when the input is 6? What do you get for your output? -3. Okay, go ahead and copy that, and then we'll do the other two. So now we're trying to find missing x values, missing input values. They've given us the outputs, which are the y values. So this time when I rewrite that equation, y equals -1x plus 3, I'm not going to write the y, I'm going to write the y value they gave me, which is -1. And then we'll do that again for the -5. In the y place I'll put -5, and then I'll put the rest of the equation. Okay, but remember, we're trying to figure out what the x values are, so what do? How can I figure out what that x value is? Right, just solve for it by doing inverse operations. That gives me -4 equals -1x, and now what do? And so x equals +4. Right, you can on this one because you can see a pattern, but not all of them are able to do that, so you'll have to know how to do this process. Okay, on this one you'll do the same thing and end up with -8 equals -1x, then divide by -1, and yes, you end up with a +8. So yeah, when you can see a visible pattern, then you can just fill it in. But you better be careful because sometimes you think that you know the pattern and it's more complex than you realize. Okay? Alright, go ahead and copy that, and then we'll go over number 4. Right. Okay, number 4 is the exact same type of problem, except for instead of them giving you a table to look at, they just gave you a list of ordered pairs. I'm going to rewrite this list a little bit bigger so we can see it easier. So 0, comma, blank, blank, comma, 7, 6, comma, blank, and blank, comma, 11. Okay, I just rewrote them so we can see them better. The function is y equals 2/3 x plus 5. So the very first ordered pair we have, the given information is the what value? The x value. So that means that 0 can take the place of the x, and that would become 2/3 times 0 plus 5, so y will equal what? 5. Okay, the next ordered pair, the given information is the y value. So this time you have to replace the y with a 7. So 7 equals 2/3 x plus 5. And you have to solve for the missing x value. How do you do that? Right? You get 2 equals 2/3 x by, right, the reciprocal. Okay? 2/3 times 3/2 is 1, and you don't have to write the 1 beside the x. And then what is 3/2 times 2? Okay, look, this is very easy. Look, because isn't 2 the same thing as 2/1? 3 times 2 is 6. 2 times 1 is 2, so 6/2 is 3. I know. Okay, the third ordered pair, they've given you what? The x value. So you can take that 6 and replace the x with a 6. What's 2/3 times 6 plus 5? 9. Okay, because 2/3 times 6 is 4. Think about it. If there's a pizza sitting there with 6 slices and you eat 2/3 of it, that means you're eating 4 of the 6. And then you add 5 to get to the 9. Okay, now in the last ordered pair, the given information is the y value. So you'll replace the y with the 11, and then from there you'll have to solve for x. So what do we do first? Those cancel out. We end up with what on this side? 6 equals 2/3 x. And now, just like we did over there, you can either divide by 2/3 on both sides, or you can multiply by the reciprocal 3/2 on both sides. Now, when you multiply a fraction by its reciprocal, it's 1. It cancels out. That's why we do it. And on this side, don't you end up with an 18 on top and a 2 on bottom, so 9? Okay, go ahead and copy what it's called. Number 5, given the function, complete the table. Okay, so the function this time is the square root function. The first input and output are both complete, so we don't have to worry about those. Remember, this 1 is a what? An x value. So we'll replace the x with a 1, and the square root of 1 is 1. Okay, then 9 is also in that column, so it's also an x value. When you replace the x with a 9, the square root of 9 is 3. Now, you can, if you want to, replace the y with a 2 and solve for x, and replace it with a 5 and solve for x, or you can just use your common sense. The square root of what x value would give you a 2? 4. And then the square root of what x value would give you 5? 25. Okay, number 6. This time you're going to be filling in a mapping diagram using this quadratic function. It's quadratic because it's squared. Okay, this is square root function. This is a quadratic function. Now, do we need to plug in a negative 2 right here? No, why not? It's already paired up with a y value. The first x value we need to plug in is what? Negative 1. So a negative 1 will go there. You add 1 to it and you get, and you square 0 and you get 0. Okay, then this x value of 0 is already paired up with this corresponding y value. Now we need to plug in a 3 into the x. 3 plus 1 is 4 squared is 16. Okay, now go to page 35. Okay, set 1. Javier has designed a simple robot that can pick up blocks and stack them into groups. The table shows how many blocks a robot can stack in a given time period. Alright, the input values are 1, 2, and 8, and they represent minutes. So like 1 minute stacking, 2 minutes stacking, and 8 minutes stacking. The output values are also 1, 2, and 8, but they represent the number of blocks stacked. So like in 1 minute, the robot stacks 1 block. In 2 minutes, it stacks 2 blocks. So 1 block per minute, right? The equation that would represent this is y equals x, because if these are the x's and these are the y's, aren't they equal every time? Okay, how many blocks can the robot stack in 19 minutes? Right. Alright, number 2, use the function for the pattern shown in the table. Remember the other day how I told you sometimes instead of y they use f of x? It's the same thing. So this time if you're writing them above, you can write x for your inputs, f of x for your outputs. This can just be used interchangeably with y. Okay, so what do we do with this 0? Put it in the x place. What's 1/4 times 0? And 0 plus 1 is 1. What do we do with the 2? Okay, so type that in. 1/4 times 2 plus 1. It is 3/2. Let me show you what you can do though. Say that, okay, see how the rest of these are written in a mixed number? And so say on the test that the answer choices are in mixed number form. Let me show you how you can change yours to a mixed number. Okay, alpha y equals n over d to put in the 1/4 first. And then beside it I'm inputting what number? Isn't it a 2? Yeah, 2. And then add 1 and you get 3/2. But say on the test you don't see 3/2 because all of them are in mixed number form. Go back to alpha y equals and look at that choice number 3. See how it's n over d for like numerator over denominator, which is what we currently have, and it changes it into a mixed number. So hit number 3 and then hit enter and it makes it a mixed number for you, 1 1/2. Okay, now the next two blanks are missing input values, so missing x values, but they have given you the corresponding f of x values. So what can we do with those? Well, I'm just saying on the multiple choice test, if you get 3 over 2 and that's not one of the 4 choices, you need to quickly figure out that 1 1/2 is the same thing. So you can either use the calculator or just however you want to do it. Like if you say that you did this, say if you don't remember how to do what I just showed you, you can just type in 3 divided by 2 and 1.5, and I'm pretty sure then you'll be like, oh, that's 1 1/2. Okay, now for this one, 1 1/4 is an output, so it's an f of x value. So in the f of x place, I'm going to put 1 1/4. And then I'm going to write the rest of the equation. And now I need to solve for x. So what do I do first? Subtract 1. And that, yes, that just leaves 1/4 equals 1/4 x. And now, how do you get rid of the 1/4? You can either divide both sides by 1/4, or the same thing is to multiply it by 4 over 1. Keep it, change it, flip it. Now, on this side, the x's cancel each other out, and so do the 4's, leaving x by itself like we wanted. And then on this side, what's 1/4 times 4 over 1? 1. Okay? And now you can pretty much use your common sense to know this input would be 3. All right, number 3. Use the function for the pattern shown in the table. Y equals 3x minus 1. Okay, quickly try that one by yourself. What did you get for the output when the input was -4? What did you get? Look, if you plug in -4 and multiply it by 3, you get a -12, and a -12 minus 1 is -13. Okay, what do you get for this input when the output is -4? -1. What about when the input is 3? 8. 3 times 3 is 9. 9 minus 1 is 8. Because -4 is a y value, so I put it in right there. And then I solve for the x by adding 1 to the other side, giving me a -3 on the left, 3x on the right. Then when you divide by 3, that becomes a -1. Shh, boys. What do you get for this input when your output is 20? 7. Okay. Now I want you to try page 36 by yourself. I'm going to give you about 5 minutes. All right. Number 4. This is what you should have got. When your input is 0, your output is -11. When your output is -7, the input is 1. And like Naya said earlier, but I don't know if y'all heard her, you can check it by putting the 1 in for x. 4 times 1 is 4. 4 minus 11 is -7. Or, like if it's multiple choice, couldn't you just take each number, plug it in for x to see which one gave you that? Okay, when your input is 2, your output is -3. And when your output is 1, your input was a 3. Okay, number 5. When your input is a -1, that negative makes it a +1 minus 2.5, so -1.5. When your output is a -0.5, your input was what? -2. When your input is -3, your output is 0.5. And when your output is 1.5, did anybody get the input for it? -4. Hard to write that small. Okay, set 2 is the absolute value of x. So if you take this -5, which is in the input column, so all of those numbers are x values. So if you replace the x with a -5, what is the absolute value of -5? +5, right. Then you could take the 3. What is the absolute value of 3? No, absolute value is always positive. So if it's already positive, it stays. Number 2, the reason absolute value is always positive is because the absolute value of a number is the distance from 0. Well, can distance ever be negative? No. So that's why it's always positive, because it's distant. Number 2, what are you going to do with this negative 4? Put in for x, and 1 over negative 4 is negative 1/4. Okay, then 1 right here is our output value. So we're going to put it in the place of f of x. And now we need to solve. 1 divided by what number equals 1? Right? And now we plug in 3. And when you plug in 3, don't you just get 1 over 3? So 1/3. Okay, number 3, y equals x cubed, the cubic function. Okay, this one's already been done for you, so we need to cube negative 1. If you don't know how to do that in the calculator, I'll show you. Anytime you're typing in a negative number, you put it in parentheses. And then to cube it, you hit this button over here, the below clear and above division, and see how it made a little exponent box? And then you type in whatever number you want for the exponent, and you get negative 1. Okay, you do the same thing with 2. What is 2 cubed? 8, because it's 2 times 2 times 2. Okay, now we have a quadratic function because it's x squared. Okay, what is 1 squared plus 5? And what is 3 squared plus 5? Right? Because it would be 9 plus 5. But then this one, where do we put the 21? So 21 equals x squared plus 5. Now to solve for x, what do? You didn't finish it. Subtract 5, and you get 16 equals x squared. And then to get rid of a squared, you square root it. So the square root of 16 is 4. Plus, you can kind of see the pattern in that one. Okay, your homework tonight is going to be the review sheet. I'm about to pass it out. The front page will count as a stamp. The back page will count as a second stamp, totaling your stamps to 4. And we are turning in the pink sheet tomorrow